I want to show you how to connect to the PLC and program it. I'm just going to search for the Click programming software, and you'll notice there's a project loader and the programming software. We want the programming software. When that comes up, you'll reach a startup window every time. You can either open whatever you're working on from here, you can start a new one. I always say connect to PLC. Now, in a lot of the demonstration videos, you'll see people start a new project and then select the PLC they're working with. If you just connect to the PLC, then it will detect what kind it is. Now, there's actually a couple of different PLCs. There will be PLCs that you are working with, and those are connected via USB. You'll see a little cable that runs from the PLC, and there's a USB. There's a little blue box that converts it from serial to USB. USB is also technically serial, but to a standard serial port. Anyway, so you'll plug it in. The easiest place to do that is just right on the front of the computer. You can reach around and plug it in the back if you really want to, but in my experience, the front ports work just fine. If it can't detect the PLC, try moving to a different USB port, and it should work. Anyway, when you hit USB, it'll come up with a COM port number. I always hit detail, and then it should show you the Koyo USB serial COM port. Whichever one that is, doesn't matter what the COM port number is. It can be COM1, COM4, COM20 for all I care. If it has that note right there, Koyo USB serial COM port, that's the one you want. So hit OK. It happens to be that that was COM4. And then I don't mess with the auto detect or anything. At this point, if it has that Click Koyo USB as an option in the COM list, then it should work just fine. So I have an option here. I can either read the program that's in the PLC or don't. So what I'm going to do, I'm going to go ahead and read the program that's in the PLC so you can get an idea of what the programs kind of look like. But then I'm going to make my own program, and I'll show you how we use these and how they work. So right now it's just pulling all the data from the PLC. Let's see, project has been saved with an earlier version of Click Program. So the program that's on the PLC was written with an earlier version of this software. Do I want to save? It doesn't matter. This is some student project from the past. That grade's long been submitted, probably last year. Yeah, this is one of last year's projects. I recognize it. So anyway, this is a PLC program, and I've made it full screen. Obviously, I've posted some videos where you can see some other items and information, some of the kind of the overview. But I want to show you a little more detail. There's a lot here. I don't really want it all. You can't, unfortunately, select a bunch of rungs at once. I just held down the shift button. You've got to delete them one at a time as far as I can tell, but if I click on this and I hit D, no, that didn't work. That's alright. We'll just delete all of these rows. I could hit new, but if I hit new, it will make me choose the type of PLC. By the way, one thing you should know about is under Setup System Configuration. I think there is an icon for this somewhere up here. I can never find it. That's syntax check. So I always just go up to Setup and then System Configuration. There are differences between the configuration on the PLC and the PC. What this means is that this program that's been brought up thinks that it's working with a certain PLC that has certain input-output cards. But the real PLC, the one that I'm literally connected to right now in the lab, is a different configuration. So I have a choice. If I say yes, use the system configuration in the PLC, which I'm connected to online, or use the system configuration of the PC. In other words, do you want me to go out to the PLC and see what it actually has and use that? Or are you programming on a PLC where you know it's just temporary and you're actually going to put it on some other PLC that has a different configuration? Well, in this case, I want it to actually go out and say, okay, what do I have that's there? What PLC is this? What I/O modules does it have? What are their address ranges? All those things. So the option I would choose is yes. That way it'll go to the real PLC and find out what all it has. And my whole reason for doing this was to show you this screen and show you how nice it is. It's a really convenient area. So it's just telling me that I can edit the power supply. It can't detect what power supply it's being given. It's just a 24-volt supply. But I wanted to show you this because it's really nice. It goes out and it detects which PLC is being used. So there's the model number. So you can look up the data sheet on it. And it tells you all the modules that are connected. If you were looking at this PLC, this is what it would look like, except of course you'd be able to see the power supply as well. Now, it's not easy to see this. You'd have to zoom in a little bit, I guess. You can connect to it also the way I'm doing. I'm actually at home using the lab remote stuff that I posted you information for. If you can't find that, let me know. I'll tell you where it's at. It's in the laboratory information area. But I really like this because it shows you what are all the inputs and all the outputs associated with each one of the items. Now, one thing I don't like, they don't line up. So the CPU is actually over here, the IO1 is here, IO2 is here. I wish they expanded the tabs so it was just beneath, but small human factors thing. So the PLC itself has several different inputs. They are X001 through X004. Those are on-off discrete type inputs. So we'd wire up switches to those. And we only have 4 inputs on the PLC itself. Technically we have 2 more inputs, but those other 2 inputs are analog inputs, and they come in to the PLC in a different address range. See, all these inputs get read by the PLC every cycle and then put into memory. So what this is really telling you are the memory addresses where you can find the status of everything connected to the PLC. So if I had a switch connected to input 1 at X001, I could reference address X001 and I would be basically looking at that switch. I would be getting information from that switch because it's connected at X001 at a particular input point on the PLC. Now for analog inputs, I've got DF1 and DF2, and one interesting thing about this particular PLC is it has analog current and analog voltage inputs, and we'll talk more about that later and how you use them. But notice the addresses look very different. They're a DF address instead of an X address, and that just means, I think that means it's a floating point number. That's what the F probably stands for. X's are commonly used for inputs and Y's for outputs, and then F for floats. Where the D comes from, I don't know. It doesn't really matter. The outputs that the PLC module, the CPU itself has, well, there are 4. They are Y1 through Y4. Now notice it's Y001 and Y004. And the reason for that is because you're likely to have a whole lot of discrete or on-off binary types of inputs, outputs. And you aren't likely to have very many analog inputs and outputs, at least for this class. And even in the real world, a lot of systems run with just, discrete I/O. But you may need some. So the other addresses for other modules, sometimes you can assign them if they're analog addresses. Sometimes you can select and arrange. The discrete addresses, though, are automatically assigned essentially by module number. So you'll notice while we have Y001 through Y004, we have Y101 through Y108 for the next module, which is an input, that's an output module. What am I saying? It's a Y, so it has to be an output, right? So there's an output module as the first expansion module on the side of the PLC, and then there's an input module daisy-chained off of the output module. And it provides X201 through X208. Notice that the number right after the X or the Y indicates the module position. So that's nice to know, but not necessary. You can always go in here and look. But we've got 8 inputs on this last card. We've got 8 outputs on the IO1, and the PLC itself has 4 inputs, 4 outputs. So that's a total of 12 inputs and 12 outputs as far as discrete inputs and outputs go. So not only do we have the analog inputs on DF1 and DF2, but we have analog outputs on DF3 and DF4. Now, let me show you the memory in the PLC, and you'll notice that the X's kind of are in their own area. The inputs are in their own area. The outputs, Y's, are in their own area, even if they're on a different module. But the DFs, whether they're input or output, they're all in one memory table. So let me show you where that's at. I'm just going to hit OK here. So if I just click on one of these addresses here and I say I want to change it, so it's a bit memory address, I'm just changing what address this particular instruction is referencing. Click the 3 dots. You'll notice I can choose from the X's, which are all inputs, and notice it's set up very nicely where we have X001 range, X101 range, and X201 range, and so on. I'm going to choose the X001 range. You notice there's no X000. One of the interesting things about click PLCs that is not usual is that they don't start counting from 0. Now, technically the memory still does because computers by default count from 0. 0 is a valid number. But I guess to avoid confusion, they started all the inputs at input 1 and so forth, so you don't have an input 0, and all the outputs as well. That causes a little bit of trouble later for us, but it's not difficult to figure out what to do. But this is one unique feature of the click series, is that it starts at 1 instead of 0. So if we were interested in the modules on, let's see, that second one was all outputs, right? So there wouldn't be any X's. Like if I looked at X10 range, there's nothing there. You notice that it only goes X101 through X116, and then the X2 series begins. Now I could just click X201 and it would just scroll down to that. Or I can just grab this bar and scroll down. I mean, it's easy enough. But this would be the inputs on that very last expansion module. And it's got a nickname. I don't know. I guess these came from the probably from the programming that my students did, or maybe this is a default. I've never seen it give a default, so this is probably yeah, zone 1, 2, 3. This looks like. And since they didn't go all the way through 8, then this must be something that's coming from the program that I opened. These are just names from the program. So don't worry about those. You can put names in, by the way. All you have to do is choose edit mode. And if X201 is a particular limit switch, like let's say X201 was a, I don't know, an end of line switch or something. So we could put end of line. And it's pretty common to put NO or NC to indicate whether the switch is normally open or normally closed. You'll notice my students in the past put LS and POS. POS was for positive, NEG was for negative. I don't remember what that was for. It was something to do with the game they made. But LS stands for limit switch. And limit switch, having that in your program doesn't really add a lot of detail. I mean, you can if you want. I prefer to have normally open or normally closed so that later on when I'm programming I can use it. It's a little more beneficial in my opinion. So right now I'm in edit mode, and I could go to pickup mode, which is where I'm actually choosing the address that will go into this instruction. If I hit OK, for example, I was on, I had X202 highlighted, so that it puts it in. If I hit OK, then that becomes the address that this instruction is referencing. So basically what this instruction does is it allows power to pass if, for one thing, power is coming in. The previous instruction has to give power to it. But it also only allows power to pass if X202 is true. Okay, so X202 is a memory address that's either true or false. Now, the switch attached to that particular input, which, what would that be? Well, if we go to Setup, System Configuration, can't point to the real PLC because I don't have it here, but X202 would be this last module. It would be the second input point on that module. And it's labeled 2. So it'd actually be the third terminal, because there's a, I've forgotten what the first terminal's labeled. It's a common or something. But it's this, the third terminal down is the second input point. And so that's where the switch would be physically wired that then drives this memory address X202. I can't turn on or off X202 in this program. It's driven by an external switch, right? That's what determines the status of that memory address. Now I can override it. I can force it. I can pretend that it's on. But I do that in software. I don't do that in PLC programming. So as far as I know, there are no force commands in PLC programming. But there are force commands in this software where you can simulate a particular input coming on. And you can simulate outputs turning on and so forth. So let's make a very simple program. Let's get rid of all of this stuff. They're usually not very long programs. As a matter of fact, I've posted several videos of student projects in the past, and while you can't see the code necessarily, and I don't think I actually have the code or I would post it alongside, while you can't see the code, I will tell you that the first project in the class has less code requirement than the second. And it's pretty common to have a program that's 20 lines or so for the first project, and maybe 50 to 100 lines at the most for the second project. This will all disappear pretty quickly, believe it or not. No, I said it would. How far does this thing go? It might be quicker to just make a new. How far does it go? Yeah, I'm gonna make a new one. This one's longer than I remembered. I'd have a lot of time deleting. If I could just select everything and delete it, I would. But let's see, they don't have a way to do that. So that I'll have to give up. I'll have to say new file, but I want to make sure I get the correct PLC. This is an O2 DD1D. Okay, I can remember that, I think. So new. No, I have no desire to save that. Open system, or start a new one. So that was what, an O2 DD1D? There, right there. So I'll select that one. It gives you some good information here about what inputs and outputs it has, which you've already seen. It tells you the output type, which is DC syncing. I'll explain what syncing and sourcing is later. Right now it doesn't matter too much. Power consumption, 140 milliamps. That's important for your power budget. The power supply you have driving the PLC needs enough for that PLC as well as however many modules you have. So I need at least 140 milliamps coming out of my 24 volt power supply, which I have. I think I spec 1.2 amp, I think it was, for these is what we've got. Anyway, so now we've got a blank program, and I just wanted to write a very simple program for you. What if we wanted to make a switch turn on a lamp? Well, we would need an input. So we'd have to wire up a switch to one of the inputs. And let me get out of this. Actually, if I go to Setup, System Configuration, yes, it needs to detect again what the PLC really is and what all's in it. So I'll say yes. And it's talking about power budget here, saying you got to make sure you've got enough power to supply all of the modules. I don't know what power supply you've got, is what it's saying, so you need to check and make sure you got enough power. I know I have. So we're back where we were. It's still the same PLC we're connected to, right? But I could choose to wire up an input to any one of these on the CPU module, any one of those 4 inputs, or I could wire up an input to module 2, which is out at the end. It's kind of interesting they start from 1 with all of the input addresses, and yet technically the CPU is module 0, because you notice the module number really is that number right after the letter. But like I said, this is kind of unusual that the inputs and outputs don't begin at input or output 0, but it's a small thing. You get used to it. So I could either wire up inputs to the CPU or to this one. I cannot wire up an input switch to the output module. An output module only provides output. It can't take input. So that's something that's pretty important. So I have to choose an address that is from X001 to X004 or X201 through X208. And then I would have to wire up my switch to that particular point. And then I could reference that switch. And the way I would reference it is with the address that I wire to. Let me go into the address picker. You can just type in the number. I could have typed just X001 if I wanted, but I wanted to give it a name, so I'm going to hit edit mode, and I'm going to name it, I don't know, light on, and I'll call it a normally open, so NO switch. Go to pickup mode, that one's selected, hit OK, and so X001 is there. Now notice that it gives me the name here. It's really important that when you choose an address and you wire up a switch to it, that you give that point a name. It makes your programming a whole lot easier to understand. It makes it easier to write. It makes it easier to troubleshoot. Trust me, you desperately need to put names on everything that you're going to use. It will save you in the long run. Okay, just start out doing it, and I will take off points for programs that I see where you have not labeled the inputs and outputs that you are using. It's very important. And I also highly recommend that you put rung comments on your rungs. In fact, the way you do that, let's see, edit rung comment. You just right click on the rung anywhere. I don't know if you can right click. Yeah, you can. You can right click on the rung number and hit edit rung comment, and then you can just name it. So this rung turns on the light. Okay. And then there's a little comment there that you can read, and you see what that rung is supposed to do. Or maybe this rung and the next 3 turn on the light. Whatever it is, it's just comments. If you've ever, well, all of you should have programmed by now. So any programming language you write in, the teacher always tries to get you to comment your code. And I know that because I've programmed in so many different languages. I know what a pain it is when you don't comment your code. There might be one language where you don't. It was a programming language I used in artificial intelligence class. I think it was called G or something like that. And you were supposed to program it in English, and there was still a lot of syntax to worry about. But you could read what it was saying and understand what it was supposed to do. So I don't remember us using comments in that particular language. But that's the exception by far. I programmed in C, assembly, all kinds of languages, and you always want to comment your code. So what I've done now is I've dragged an output to the end of the rung to be turned on. So this would be where I'm going to wire up the light. So let's choose an address, and notice that we can't choose any of the X's. Did you notice when I was working with the instruction that was an input to turn the light on, I actually could choose outputs there. I'll show you how we would use that in just a second. But notice that right now I can't force an input on by referring to the address of an input. I can only turn outputs on or affect memory addresses. That's what this control relay or C addresses are. They're just bit memory. And then there are system control relays, but we'll talk about all of that later. Right now, let's just grab an input. I'll just choose Y001, but I'm going to name it. So let's call this green lamp. And then pickup mode. I'm just making all this up as we go. And there's some options here, one shot and immediate. I'll tell you what all that means later. Don't worry about it right now. We'll just hit OK. So now we have selected the green lamp as the output. So what happens is every time this program runs, which by the way it wouldn't run yet, I forgot to put an end on it. That's another odd thing about Automation Direct is they require an end statement. But it's fine, it doesn't matter. You just get used to adding it. And if you don't add it, it just throws a syntax error and basically tells you to add it. I wish they would just automatically add it, but I don't know the reasoning. But you just put an end after all your code. And if you need more space, you can actually just drag right over this, put something else there. I'm going to cancel, I won't do that yet. I will in a minute. So anyway, if we were to download and run this program on the PLC right now, any switch connected to input 1, which there would only be one, you can't connect multiple switches to one input. A switch could be closed. If it was normally open, it could be closed, and when it was, then this instruction would pass power and output a true value or turn on the output on Y001. So this is all on the CPU module because these are both 0 addresses, right? X0, Y0. They're both on the CPU. I don't have to do that. I could wire up my lamp. Say I want to wire it up to module 1, right? Because remember, module 1 was an output module. Now obviously, if I take those two output modules, which are just daisy-chained on the end of the CPU, I take them off and I flip them around and put them back on so that now instead of having CPU output input, if I instead had CPU input output, all my addresses would be messed up. And I'll show you something you should do later in the course. It's called mapping input outputs. I'll show you that later when it's more relevant. But it'll save your program when you go and change things around, change the physical wiring a little bit. Mapped I/O can be very useful for future changes and things. It gives you some degree of flexibility as well, and will help avoid problems when there are wiring changes. Anyway, so when I press this button, that lamp will come on. Notice I've broken a rule here. Can you think of what rule I broke? I didn't name this. How did I end up not naming it? Oh, that's right. I was going to use address Y001, which I did name, and then I changed the address, didn't I? So I forgot to change this. So now let's go to Y101, and let's call it green lamp. This name already exists, it's assigned, so it won't let me. So I've actually got to delete this one first. Then I can go, so it won't let you name anything the same as something already, which I think is good and bad. I can see both sides. So anyway, there we go. Green lamp, pickup mode. I will choose that one. Okay, it didn't change. And now you can see it's named properly. Alright, now let's just say that anytime this green lamp comes on, something else needs to also come on. I don't have to reference this address. Because I have this address being turned on, I can actually reference this address. So let's just pretend that whenever the green lamp comes on, a motor should start. Okay, so I'm going to drag an output over here. I'll grab another address, and we'll just continue with our pretending that there's a motor connected to Y002. Okay, so we'll call this motor. Lack of a more creative term. Okay, so Y002 is the motor. If I, for some reason, do not want to reference this particular address, I don't have to. Because Y101 comes on, I can reference that address. So what I'm trying to say here is that output addresses can be used as conditions. Everything between the numbers here and this vertical bar after cell or column T all of that, those are considered conditional things. They're the logic that determines what the output should be. So all the PLC really does as it scans, besides all the overhead stuff, when it's running the program, what that really means is that line by line it evaluates the statements and decides whether the output should be triggered or not. That's all it really does. And don't think that that's a weak thing. That you can make some very complicated programs with just that functionality, and I'll show you some as we go along. But a lot of times what will happen is that the conditions for a particular output will be pretty complicated. It won't just be this. You'll have a bunch of other instructions, you'll have some branches, you'll have some other things in there, and it's a big pain to just copy that and put it on another line where you want the same condition. So rather what you do is you simply use the output that's already been calculated and use that to drive another output that is supposed to be identical. I actually use this in kind of an interesting way in my boiler heat setup. I've got a set and reset output. These outputs that I'm showing you right now that just say out, they can turn an output on or off. But set and reset, on the other hand, are I'm just going to give it some addresses really quick here, and I will name it in just a moment. Set and reset are the latch and unlatch, basically. So set is like latch, reset is unlatch. And sometimes what you want to do is just have an output instruction that can only turn on the particular memory address. So in my heating system, I've got two different valves, and the valves should basically just always be opposites of one another. If one's open, the other one should be closed, and vice versa. It's that simple. So I have an output instruction that controls one of the valves, let's say kind of like this motor here, and what I've got is conditions. The conditions for turning one on and the other one off are a little bit different, but basically I invert the output. So for example, I might invert Y102, and that's what determines that Y001 should come on. When this turns off, this one should come on. And what is it? Well, I should name it, but I'm just illustrating the idea here. So I can name this valve 1, and this one would be valve 1 as well. And usually when you have a set, you also have a reset, and they reference the same addresses, because if you don't have the two, you can't turn it both on and off, because like I said, this instruction can only turn on address Y001. This one can only turn it off. So if you ever want the output to go off after it's come on, well then this is the way you do it. Now why would you ever do this when this instruction can do both? It can turn on and off. Well, by default, there's no way to change this that I know of where this instruction isn't a simple inverse of all the conditions on the rung before it for the opposite case. What do I mean? Well, for this Y102 to go on, let's use Y01. For Y01 to come, or Y101 to come on, X001 has to come on. If X001 is off, then Y101 is off. So the conditions for turning Y101 on are just the opposite from the conditions of turning it off. The nice thing about having the set and reset is you don't have to have exactly opposite conditions for turning it on in one case and turning it off in the other. Like the condition for turning this on could be that motor turns off, that motor 102 goes on. And let's just pretend this is a valve. Let me name it. That's bothering me. I gotta name it. Hang on. So we'll name this edit mode. We'll just call it a valve. We'll pretend it's a valve in my heating system. Okay, that should pick it up. There we go. Okay, so now it's got a name. So the valve, the valve, it's supposed to be V-A-L-V-E. Oh well, you get the idea. So the valve will only turn on when the motor turns off. But what if I have some other conditions? What if this is not, I don't want just the opposite here. What if I want X? Let's use 101 here. Okay, so we'll go and name that real quick. Let's just pretend it's some other input in the system. Maybe this is a limit switch. Let's see, end of line, normally open limit switch. Okay. Pickup mode, we'll grab that one, hit OK, that's fine. So notice that the conditions for the green lamp coming on, which is just a switch closing, are different than the motor coming on. That's this end of line. What if I want the condition for the valve to go on, being that the motor's off, but I want the condition for the valve to turn off to be when the lamp comes on? That's completely different. That's independent of the motor. But maybe for some reason in my program, what I really want is to only turn off the valve when the green lamp goes off, you see. This is the only way I can do it. I can't control this valve output 001 with the motor itself, or with an output like the motor has, or with an output like the green lamp has. I have to choose the conditions for turning the valve on that are right here that are different than the opposite of that as the conditions for turning it off. Because if I just had an output right here instead of set, then anytime the motor turned, let's see, we need to inverse it. So anytime the motor turned on, then that would shut the valve off, right? But anytime the motor's off, the valve would come on. They're just opposites of one another. Those aren't the conditions I want. So when the conditions you want for on are different than the opposite of conditions for on, then you have to use set and reset. And maybe that'll make a little more sense later. But set and reset are very powerful commands. They're very useful. And they're kind of nice because it takes a little bit of getting used to buttons that, you know, when you push them, they don't stay pushed. You may be a little more familiar with that because buttons on your cell phone are momentary type buttons as well. But light switches, which most people are very familiar with, and they think of light switches as turning things on. They usually don't think about a volume button as turning things on, maybe a power button on your smartphone. But toggle switches kind of get you in the mode of when I flip it into one position, it turns on and it stays on unless something else, unless I come back and change it. And so students sometimes have a hard time wrapping their heads around switches that are momentary and so go off when you release them, and outputs that can both be turned on and off by a set of conditions. They're used to programming also typically, and they're used to when I turn on a variable, it just stays on. And they don't think about that this program is going to come back in the PLC and it's going to reevaluate this instruction or this line every single time, maybe every few milliseconds. And so it's possible that it will come back very quickly and turn off that output that I thought was on, or that condition I thought was on. So with all that being said, that's just a quick introduction. I haven't actually connected anything to the PLC. I'm connected to it for programming purposes, but I don't have the switch and the light hooked up. And there's a lot of detail with that I'll have to teach you about inputs and outputs, because if I look up this particular model, the way that I connect the inputs and outputs are really important. I have to know what I'm doing with this. There's this thing called syncing and sourcing, and one of the things that really confuses students is they seem to think that this output module, if they connect a lamp to it, all they got to do is take the two wires from the lamp and plug it right into the socket and it'll work. These output modules don't work that way. They don't have power to give to field devices. You have to somehow give power to the module that the module can switch. So all you're really doing is giving the PLC control over the light switch itself. Okay? But the PLC doesn't have the power to drive that lamp. You have to connect the power wires themselves, and I'll show you how to do all of that when I talk about module wiring. So this is a simple program that does very little, but hopefully you learned a few things from it.